All right, so this last part about the statistics and sample gathering and everything that we're going over in this chapter is about the normal distribution. Okay, and the normal distribution is also called the bell curve. So if you ever heard the term bell curve, what we're talking about is the normal distribution. And basically what that means is that if you can think of what a bell looks like, if you think of what a bell looks like, it starts, in the middle of it, it's very tall, and then it goes down symmetrical on both sides. Okay, so it's symmetrical on both sides, so you can kind of fold it in half, and it's exactly the same. That's a bell curve. And one of the main things here is that the highest point is always at the 50th percentile, and it's always the mean of it. So the mean and the median, the 50th percentile, is always the same number in a normal distribution or a bell curve. Okay, it's the same, because if you fold it in half, you get 50 on one side, 50 on the other. Okay, so that's what we're going to be looking at, and looking at different things with that. So the big thing here with the bell curve is something called the empirical rule, and the empirical rule basically helps us divide up this bell curve into percentages and groups. And so as you see here, we've got all these different percentages inside of it, and what it's saying is that from here to here, this part right here, there's 34% of all the data is right here. Okay, so 34% of all the data is in this purple box. Okay. 34% is in this purple box. 13.5 is here, 13.5 is here, 2.35 is in the blue, 2.35 is in this blue, and everything. Okay. Now the key thing here is looking at, okay, well, what's dividing these? This isn't, it's not just, oh, this is where the line is, this is where the line is. They're all deviations apart. So from the middle to that first line right here, that distance is one standard deviation. From this next one to the next one, that's another deviation, or two deviations from the mean. And the next one would be 3 deviations from the mean, and then so on and so forth. And it's the same on this side. That's one deviation. That's one deviation. That's one deviation. Okay. So as you see, what it is, it's one deviation away and everything. Now, the empirical rule says that if you're one deviation from both sides of the mean, so if you look back here, if you're between here and here, so if you're this part right here, so if you're one deviation below and one deviation above the mean, you are going to include 68% of the data. Of all the data points should fall within one deviation above and below the mean. Okay. Now, if you're two deviations on both sides, so if you're two deviations above and two deviations below, you're going to be 95% of the data is going to be within that range. So as you see, almost all the data is within 2 deviations from the mean on either side. And then the last one says that if you're 3 deviations, 99.7%, or essentially all of the data, is within 3 deviations from the mean. Okay. Now, this rule has another rule that's easier to remember. Okay, you want to know what it is? It is 68, 95, 99.7 rule. That's another name for it. So if you ever hear somebody say the 68, 95, 99.7 rule, they're talking about the empirical rule, which basically means that one deviation is 68, 2 deviations is 95, 3 deviations is 99.7. Okay. So that's how many deviations you are away, and that is the percent of the data that falls within that range. Okay. Pretty simple. Pretty easy to remember. Okay, so that's the empirical rule. All right, so now using a z-score, one thing with a z-score and this is that you can get a table, and it tells you what percent or what percent of the data falls between the mean and your value, and you go by the z-score for it. And so what we'll do here is that when we're looking at this one, we'll go, okay, in a normal distribution, blah, 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 the mean is 58, and the standard deviation is 5. What's the z-score for a score of 98? So if we were to plug everything in, okay, so we have, again, this should be kind of review. We talked about this a little bit ago. It would be 98 minus 86 all over 5, which gets you about 2.4. So you're about 2.4 deviations away. So now if we were to look at this on our curve, so here's our mean. X bar. Our mean. Here's 1 deviation. Here's 2 deviations. And so that means we're probably about here. Okay. So now the question is, okay, well, about how much percent is below this? So how much is this whole thing? What percent of it? And so what we'll do is we look back at our percentages. Well, this was about 34, right? 34. And 3 deviations, or 2 deviations away, is about 95% of the data. So that means we're higher than the 95th percentile. We're probably up to about 98-ish. 98 maybe. Yeah, about 98-ish percentage. But just by using these different things. So if you see here, if I were to say, okay, if you look here, we were above the second deviation, so 1, 2. So we were somewhere about here. Okay. So then what you would do is you would add up all these percentages. So you've got, 0.5 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5, and that gets us, so from here over is about 97.5% of the data. And now we also want to include probably about, one more percentage, so we're probably about 98.5, 99% estimated from there. So if you want to go, okay, what's from the lower, this point to this point, what percent falls within that range? You would just add 13.5 and 2.35, okay, depending on how many deviations you are away. And that helps us find the percentage, and then you multiply that by the total number, and that tells you how much of the data falls within that range. So what percent of the data falls between the number that is 2 deviations below the mean and 1 deviation above the mean? So you're going to go back to this. This is for your IRAT. You're going to go back to this, and you're going to go, okay, 2 deviations below. Where is that located? And then 1 deviation above, and then add up the percentages. Okay. So that's for the first one. The next one, you have an average score. The average score of a video game is about 450. Francis has a score of about 780. And his score is about 2.7 deviations above the mean. What is the standard deviation? So you're going to use your z-score formula, and you have to find sigma. So you know x, and you know x bar, and you know the z. You have to find sigma. Okay? Normal distribution, statistics, and we are out.